Okay, let's turn to the next problem set, which is very similar. So a study found the following. 65% of all the people have either the disease statesis or statesis symptoms, which is that the probability of statesis or symptoms is 0.65. 30% have the disease and 50% have the symptoms. Okay, so the probability of the disease is 0.3, probability of symptoms is 0.50. So some people must have again both the symptoms and disease. So if the probability of symptoms or let's start with actually the disease, all symptoms. So union, that is equal to the probability of the disease plus the probability of the symptoms minus the probability of having the disease and the symptoms. And we know that this union is 0.65. And we know that the probability of disease is 0.3. Probability of symptoms is 0.5. That means the probability of disease and symptoms must be 0.80 minus 0.15 to make it 0.65. Okay, so now we know this intersection here is 15. The total probability of disease, that's 30, so 15 is the disease only. And the probability of the symptoms only, so that's the difference to 0.5, so that's 35. So symptoms and disease are mutually not exclusive. They can happen at the same time. Assuming that symptoms and disease are independent, what is the probability of having a disease and symptoms? So under the assumption of independence, we just multiply D and S, which is the probability of D times the probability of S, and that's 0.3 times 0.5, which is 0.15. Assuming that symptoms and disease are not independent, the joint probability of, so what is the probability of S given the disease? Okay, so given the disease, is this bubble here. And that bubble is 30 and 15 over 30, so half the symptoms. So the probability of S given D is the 15 and half the symptoms over the 30, so 0.5. Assuming that symptoms and disease are not independent, what's the joint probability? Okay, so now we need to calculate the probability of D times the probability of S given D. And you see that is the difference to the earlier question. Under the assumption of independence, we just multiply the probability of D times the probability of S. But now we have the probability of D times the probability of S given the disease.
And we know that the probability of the disease is 0.3.
And the probability of success given disease, we just calculated it as 0.5. So we also get 0.15. So what is the probability of S and D? Okay, so we just calculated. And that's 0.15 as well. Okay, what is the difference between the joint probability of selecting a person with both disease and symptoms under the assumption of independence and dependence? Well, there was none, because we just have seen that the probability of S times the probability of D is the same as the probability of S times the probability of D given S. And actually, it was the other one was the probability of, the first one was correct, S and D, was it this one? So under the assumption of independence, we just said that is equal to the probability of S and the probability of D. And under the assumption of independence, the probability of D, I should have, oh goodness, okay. D and S. Okay, so that was the first one we calculated, and that was probability of disease was 0.3 times 0.15, 0.5. And then the second one that we calculated was the probability of disease times the probability of symptoms given disease, 0.3 times 0.5, so they're all the same. So the answer is there is no difference. So what we can conclude is that the two events are statistically independent. Having the disease doesn't seem to increase the probability of having symptoms. So the probability of having the symptoms in the entire population is 0.5. Well, that's the same as what people have in the population of those with the disease. Okay, so last question, because the probability of having statesis, given that someone has statesis symptoms, is not any different than the probability of having statesis without any knowledge about possible symptoms, suggest that, okay, what does it suggest? That the symptoms and disease are blank. Okay, so we know they are independent. So it must be C or D, that they are independent and they are mutually not exclusive. Or not mutually exclusive, I think that's the correct wording actually. So not mutually exclusive, it should read. Anyhow, I think the point is clear, and yeah, let's just stop here and then continue with a couple of more multiple choice questions.